Hi guys, welcome to my channel. In today's video we are going to be discussing a topic, synthetic roots in organic chemistry, and we are going to use the Southwest Regional Mock 2023 to lay some analysis and emphasis as well. So if you haven't subscribed, consider doing so that you will not miss any of the future videos. Let's get right into it. So as you can see, this is the layout, and we are going to be discussing one step at a time and get all the necessary stuff we can get for that conversion. Remember, organic chemistry synthetic route entails all what you've done so far, so as to be able to know exactly what processes are taking place. So each process will be analyzed individually. I will give the name to that reaction possibly and make all possible depictions from it. So let's begin right away. So our first compound is A, which is ethene, going to give us a compound B, which we don't first of all know. There are different conventions that can give rise to compound B, but we don't know it. So we move from compound B to compound C to imagine what must have taken place to move from A to B. It's pretty challenging, but we're going to sort out matters one at a time. So when we go to C, compound C shows that the compound has 3 carbon atoms, but we see that compound A has 2 carbon atoms. Something has happened along the line. So we will come back to compound B and say that there must have been an addition reaction taking place on this unsaturated alkene to give rise to a saturated compound, which further undergoes a substitution reaction with the addition of a cyanide group to give rise to compound C. So compound A could react with hydrogen bromide or hydrogen chloride at room temperature to give rise to compound B. And this reaction is going to be an electrophilic addition to give rise to bromoethane. So compound B is going to be CH3, CH2, Br. Or it could be hydrogen chloride used. There is no problem. We will give rise to chloroethane if hydrogen chloride is used, giving rise to B. Now, when B reacts with potassium cyanide in alcoholic medium, and then you do refluxing, it is going to give rise to a nitrile, where the cyano group is going to replace bromine, giving rise to compound C, and compound C is going to be a nitrile, which is CH3, CH2, Cn. And the name of this compound is propane nitrile, which is a nitrile, or it can be called cyanoethane. And this reaction is called nucleophilic substitution reaction, because the cyano group is a nucleophile that replaces the bromine to give rise to a nitrile. This one is electrophilic addition reaction, because we are dealing with the double bond receiving a proton, which is an electrophile, and the proton is adding to the compound, hence the name electrophilic addition reaction. Now we look at compound C, which is propane nitrile, going to give us D, and D goes to give us E, E goes to give us I, and I is lactic acid. So we cannot make any depiction as to what compound D could be without first of all going to the identifiable compound, which is compound I. Having identified compound I, we cannot go in a reverse manner to depict what E could be and what D as well could be. So we realize that compound I is a hydroxycarboxylic acid, where the hydroxy group is found on carbon 2, hence the name 2-hydroxypropanoic acid. And we realize that carbon 2 has taken an OH group. Now let's look at the reaction condition. Here is a slight error here. From all analysis after revision, you realize that this arrow is going to take this while this other arrow is going to take these 2. So this arrow is taking this one, so that the reaction will make sense as we proceed. So we see that the OH group is replacing a certain atom on carbon 2 to give rise to 2-hydroxy propanoic acid, and it is from this OH that will come in to replace that particular compound. So substitution reaction for the OH is suitable when the compound must have been a haloalkane or a halogeno compound, when the compound must have been containing a halogen, because a halogen is easily replaceable. Now compound E shows to have a halogen. Based on this reaction condition, OH minus under reflux. So it means that compound E should have a halogen, which is going to be replaced by the OH group to give rise to 2-hydroxy propanoic acid. Now let's go back to compound D. Compound D should be to convert C to a carboxylic acid. So compound D should be a carboxylic acid, so as to enable us have the terminal carboxylic group here. Therefore D is a carboxylic acid, and a nitrile is going to undergo acid hydrolysis, that is acid in water, to give rise to a carboxylic acid, CH3CH2 COOH, and the reaction condition here is reflux, giving rise to a carboxylic acid. Now in order to convert D to E, we need a halogen, and this substitution is going to take place on an alpha carbon, and the alpha carbon is the carbon next to the functional group carbon, which is the carboxylic carbon. So we expect a halogen to replace one hydrogen atom here to give rise to a chloro or a bromo carboxylic acid, most common. So therefore, if we cannot break off this OH bond to replace with the halogen, but it affects this, we should use chlorine in UV. If we use chlorine in UV is not powerful enough to break off this OH bond so as to replace the OH group, but the chlorine will come to the alpha carbon and replace a hydrogen atom, giving rise to a compound, chlorocarboxylic acid, which is now going to be 2-chloropropanoic acid. And this is the chlorine atom that is going to be replaced by the OH group to form 2-hydroxy propanoic acid. And this reaction is free radical substitution, because chlorine acts as a free radical to substitute a hydrogen atom on the alpha carbon. This one is acid hydrolysis. Now this reaction where the OH is replacing is called nucleophilic substitution reaction, because the OH group is a nucleophile that comes and replaces the chlorine to give rise to 2-hydroxy propanoic acid. The solvent that is used here in this reaction is water. That's why we will give rise to a hydroxy compound, and it is nucleophilic substitution reaction. That is basically what we have all the way from C to I. That is why it's important to be able to know where there is an identifiable compound, and you start making depictions from there. That's why we went to I to sort out what it could be, and to now think of what might have happened all along the way to I, and we have been able to identify that. So it's good to jot down this stuff, this relevant stuff, where necessary. Now let's come back to B. We see that compound B goes to give us F, and F goes to give G with reagents potassium dichromate. The dichromate is the one that is reacting, and we know that dichromate is an oxidant, so it will cause compound F to be oxidized to compound G. Oxidation is defined as removal of hydrogen or the addition of oxygen. In this case, compound G is an aldehyde called ethanol, and the primary alcohols are oxidized to aldehydes. So F can only be identified based on the fact that we have determined G. So from G we know what F could be. So aldehydes are formed when alcohols are oxidized by dichromate acidified. Dichromate is mild oxidant compared to potassium permanganate. Potassium permanganate is a powerful oxidant, while dichromate is not as powerful as it is. So when dichromate is used in limited amount, it generates an aldehyde. The oxidation does not go completely. Now, when it is used in excess, it will generate a carboxylic acid. So we expect that compound F should be an alcohol, and the alcohol is ethanol. And to convert B, we took B here to be bromoethane. So it will be an OH group replacing bromine to give rise to ethanol, which is an alcohol. So our reagent here is going to be sodium hydroxide or potassium hydroxide in aqueous medium, and then we do refluxing, giving rise to ethanol. This reaction is called nucleophilic substitution reaction because the OH group is a nucleophile that replaces bromine in the bromoethane, giving rise to ethanol. Now, it should be noted that a haloalkane can also be converted to an alkene using the same reagent, but only the solvent changes. Now let's say we want to convert B back to A. An elimination reaction would take place where the halogen will be removed alongside a hydrogen atom. The reagent remains unchanged, but what changes now is the solvent. We were going to use an alcohol in place of water, like for the case of nucleophilic substitution, to convert to ethanol. And once we use this, the OH group will now act as a strong base, which is a proton acceptor, and they will extract a proton from an alpha carbon on the carbon atom closer to the functional group carbon, thereby removing the hydrogen atom to form water. The bond that is holding the hydrogen atom will fall to create a double bond, giving rise to an alkene, hence the name elimination reaction. So to convert B to A is elimination. To convert B to E to F is substitution because the OH group replaces bromine. Let's look at G being converted to H. G is converted to H. We cannot depict exactly unless we come to I again. We see that H is further converted to I, and I is 2-hydroxypropanoic acid. So it has undergone acid hydrolysis to give rise to I, that is H. H has undergone acid hydrolysis to give rise to I. So what could be the conversion now from G to H? It must have been with the addition of a cyanide group. And an aldehyde with H cyanide is a reaction called nucleophilic addition, where we have the combination of potassium cyanide alongside dilute HCl at a temperature of about 10 to 20 degrees Celsius. These reagents will enable the compound H cyanide to be formed in the reaction. This is what is going to take place, and we say that the formation of H cyanide is in situ, meaning that it is formed and used at the same time. So this is a reaction we call nucleophilic addition reaction. I think we should form out the mechanism and see what it gives us. So first of all, we have hydrogen cyanide that is going to generate the reactive species H plus cyanide minus, and the carbonyl is an aldehyde, which is of formula this. The first stage of this reaction is a mesomeric shift of pi electrons towards oxygen, because oxygen is highly electronegative compared to carbon, and as a result there is a mesomeric shift of pi electrons towards a highly electronegative oxygen, breaking off this bond and leaving this carbon atom incomplete. So we are going to have a carbocation with this bond, hydrogen, and a positive sign here, showing that this carbocation or this carbon atom is deficient due to the cleavage of this bond towards oxygen, and oxygen has now an overall charge negative, showing that it has received the electrons. Now, since this carbocation is formed, the cyanide group, which is a nucleophile, now comes in and then bonds with the carbon atom, thereby forming back now a bond, making this carbon atom stable, generating this. So the cyanide group has been added. But we realize that in the formation of the reactive species, hydrogen, which is the proton, is still present. And since this oxygen is highly electronegative, it is going to accept the hydrogen atom and bond to it. So in our last step, we have this compound with oxygen now receiving this proton, since it is highly electron rich, this oxygen atom is electron rich, giving rise to this compound with OH, cyanide, and hydrogen. And this compound now is called 2-hydroxy propane nitride, where we have 1, 2, 3, and the hydroxy group is on carbon 2. So the name is 2-hydroxy propane nitride, and the name of the reaction is nucleophilic addition reaction. So this is a reaction mechanism for the conversion of ethanol to 2-hydroxy propane nitride. So let's go back up to what we have. Means that compound H is going to be CH3, CH, OH, the cyanide. So when this compound undergoes acid hydrolysis, it generates a carboxylic terminal N. At the level where the nitrogen goes away, 2 oxygen atoms and alongside hydrogen come in, generating a carboxylic terminal N, hence forming compound I. And this one is the same as the reaction we had for the formation of C to D, which was also acid hydrolysis. So it is the same thing with compound H. So that is basically what we have for this video. And if you found it helpful, don't forget to give it a thumbs up, subscribe for more videos, and share with your friends. And I wish you the best in your exams.